All right, good morning or good afternoon, whenever you're watching this. I'm sorry I'm not in there in person to walk you through what we're going to be talking about. I have a kind of family thing I needed to deal with, so I'll be a day or maybe two, but then I'll be back in. So what we're talking about today is what we did right before we left for break. We're talking about 6-5, which deal with rhombus, rectangles, and squares. In this question, it's going to cover a lot of what we did before we left. So that's the point of what we're doing today. We're doing homework that is going to help us hopefully remember all the things we're doing before we left for break. This is a good question. It's actually on that homework, so make sure you're following along with this video. That way you'll have one of your questions of homework done, and also it can be served as notes for the future, and it'll be just a good start to remembering everything we did in chapter 6, because this has a lot of that in it. So with no more preamble, we'll jump right in. This question says, given each set of vertices, determine whether parallelogram JKLM is a rhombus, a rectangle, or a square. Lists all that apply. So it's not saying it's only one of them. It's saying it could be any combination of them. For what we did before we left, we talked about rectangles. Rectangles came from 6-4, and that was the homework we've already done. We'll talk about that as sort of recap. And then rhombus and square, came from 6-5. 6-5, and a rhombus, all a rhombus is a four-sided shape with all sides matching. It doesn't matter where they're oriented. It could be kind of slanted. It could be kind of all together, but the idea is that all the sides match. And of course, you know what a square is. You know a square has all the sides match, and it has all angles being 90. So the key idea to this problem, one of our biggest notes from 6-5, was this idea that rhombus plus rectangle equals square. Also known as, if a shape is both a rhombus and a rectangle, then it's going to be a square. If it's not both of those, then it can't be a square. So what this is saying is basically we're going to do two tests to this shape, and then we'll figure out the third one no matter what. So it could be just a rhombus, it could be just a rectangle, it could be all three. So the first one I'm going to do is the rectangle test. And I don't have to do it in a certain order. I'm just picking this one because it's one of the earlier things we did, the rectangle test. In order to be a rectangle, this is the only question we have to answer. So if I want to know something is rectangle, I just have to know, are the diagonals the same length? So does the length of J to L match K to M? I'll put a question mark because we don't know that yet. Once again, so what I'm saying is, do those diagonals match? And the reason I know those are diagonals is because, let me pick another color. If I look at this, if I look at JKLM, I know these are diagonals because they're not touching on here. I know those are diagonals since they're not touching. So I'll need the distance formula. I'm also going to show you a way to do this with the distance formula that's not as involved as maybe just plugging it into the equation is. Just another way to think about it. So that's the distance formula. So I need the distance from J, which is -4, 1, ... over to L. Okay, That's one problem I'm going to do. And then from k, 1, -1, dot, 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 over to m, -1 to 3. Okay. So that's what I'm doing. I'm doing this distance and doing this distance. And I want them to be the exact same thing. I don't really care what the number is. All I really care about is that I get the same number. Once again, a shortened way of doing this is saying, well, how many hops do I go from my x? I'll square that. How many hops to the y? Square that and add them together. So how many hops from -4 to 4? Well, that's going to be 8 hops. I go -4 to 0, 0 to 4, that's 8 hops. Plus, that's 4 hops to get from -1 to +3. 4 squared. So my total distance is the square root of 64, 16, I think that's 80. 80. That's my distance. So the same thing over here. I know everything's going to be square rooted. How many hops from here to here? That's 2 squared. So I should already be a little concerned because that's much smaller than these. This needs to be a much bigger number in order to get to 80. We'll see what it is, but just something to note before I even get there. -1 to 3, make sure I did that one, and that is 4 squared. So this distance is 4, 16 squared 20. Those are not equal if you're not sure. So, JKLM, parallelogram JKLM is not a rectangle or a square. It is not a rectangle or a square, because remember, if I go back in time, I need both of these to work to get here. So if I already know this one doesn't work, I can't do this one. I know it's not a square, but it could be a rhombus. These two do not depend on each other. These two do not depend on each other. So I'm going to do the rhombus test next. And we'll see if it's even a rhombus. It might just be a parallelogram. We know it's a parallelogram. It's given to us in the problem, and all the homeworks are going to be like that. If you don't have it, you're going to have to use some older techniques to figure it out. So let's figure out if it is a rhombus. There are 2 ways. If we know here's a parallelogram. If we don't know it's a parallelogram, we're kind of in a difficult situation, but since we do know, we have a couple ways. One option is if 2 next door sides are congruent. If 2 next door sides are congruent, I know it's going to be a rhombus because I already know, since it's a parallelogram, opposites are going to match. So if I can link next door to each other, they're all going to be the same. And lastly, if the diagonals, not are congruent, that's for rectangles, are perpendicular. I know it's been a long time since we've done math, so to remind those what perpendicular is, that means make a 90 degree. So what I'm looking for here, I need to do a couple things. I'm going to use my diagonals again. I'm going to do this one just to show you, because the other one's very similar to what we just did, and I want to do something a little different so you can see all the different pieces that we have at our disposal. So I have J to L, and L, 4, 3. And then I also have KM and k is here, 1, -1, and then m is -1/3. I'll separate those so I can have a little workspace. So if you remember, what I'm going to do is I'm going to find two slopes. I'm going to find the JL slope, and I'm going to find the KM slope. And I want those to be opposite reciprocals. So in the likely event you don't remember what an opposite reciprocal is, for example, an easy opposite reciprocal would be 3, and opposite is going to, if it's positive, make it negative, negative make it positive, and the reciprocal is going to take it and flip it into a fraction. So if it's 1/2, it goes to 2. 3 is going to go to 1/3. So the opposite reciprocal of 3 is 1/3, and same for 1/3 is 3. So I want them to be a pair like this, whatever these end up being. I want these two slopes, and then whatever these end up being. Let's write the slope equation for those of you who do not remember it. Okay, there's the slope equation. So, the slope of JL is going to be, I'll say 3 minus -1 is +1 over 4 minus -4 is +4. So my slope is 4/8, also known as 1/2. So if my slope is 1/2 here, think for just a moment, what do I want it to be over here for opposite reciprocal? What is the opposite reciprocal of 1/2? If you said -2, you're in business. If not, you'll get them next time. So my slope is going to be 3 +1 minus -1. So, and then -1 minus 1. 4 over -2, also known as -2. So, JL and KM are perpendicular. They make a right angle. So, yes, it is rhombus. That's great. We did not know that just because of the last test. We had to do two totally separate tests to figure out what it was. So, let's go back to our very initial question. It said, given each set of vertices, determine whether this parallelogram, we know it's a parallelogram. It's a whole different problem if we don't know that, but we know it's a parallelogram. It's a rhombus, it's a rectangle, or a square. We only need to do two tests to figure out which one of these three it is. It could have been all three, could have been none of them. But we did all these things, and we can now say parallelogram JKLM is a rhombus. So I hope that is a good start to what you're doing. You have other problems in this homework that are not like this. You have some that are like this, so feel free to use this as a resource to kind of go back and see, okay, well, I need to do these two tests on each one. Are the diagonals matching? And are the either diagonals being perpendicular or next door sides being congruent? You do those two tests, it'll tell you which one it is. Make sure you look back in the book at the other pieces that help you know some of the things like what properties rhombi have. You can see example problems that match up pretty closely with the actual things. But yeah, this is your homework. Hopefully it's a good way to remind yourself what we did before break. And hopefully if I'm in class the second day of this week, whenever that is for you, we can go over and kind of summarize everything we've done so far in chapter 6. All right. Well, this would be the time I'd ask if there's any questions, but since I'm recording this in the past and you can't break the space-time continuum, I will leave it there. Thank you.